So this is Theorem part 2. So those who haven't watched the first video, you have to, because you will not get it. But anyway, let me use the ladies here to help you revise what we did in the first video. So Madam Jane, can you tell these people how you can find this angle here? Yes, me. Yes, madam. The question is, how can a person find this angle here in red?
You subtract from 180.
Oh, yeah, the SIM card bringer into the thingy. Yeah, wala basha. Bakugonga meke. Amene bakutumira ndram. There's a lady who came looking for you. Tenzena ya muintake ujamsikana out. Yeah, like same hood, but not same school. We go or how about if it comes like this? How can a person find this angle and this angle?
Those are what isosceles, however you pronounce it, angles. So the two are equal.
How can
So
one get them?
you so if that's 70 there, you subtract it from 180 and you divide it by 2.
Okay, interesting. What about this? There's a 20 degrees here. How can one get this?
They are the same. They are 20 degrees, 20 degrees.
And if this is 50 degrees, how can one find Z?
Even there it's 50 degrees.
And then how can one find T here?
It's also T. The value there is also the same.
No, I'm saying right now, what is the number here on T? Yabuela? Maybe it's because I switched and...
Oh, okay. There's a straight line there. So you subtract 80 from...
It's a 50 and 25.
It does prod.
50.
So 130. And then this theorem, what does it state? If there's a 8, if there's a 86, if there's a 25 degrees here, what angle will be in red here?
So 25 by 2. 25 by 2. That's what? 50.
Wrong. 20 divide by 2. Jambe. Diodara. Titengere njira yatwe. Aka. So you are the 25, madam, here. Okay. So you divide by 2, it will give you 22. 20, not 22, it will give you 12. 12.5 degrees. Because the angle that is at the center is twice the angle that is at the circumference. And then now, what happens to this? If there is a 35 degrees here, what angle should be here? Hmm?
Is it the I've forgotten?
Why have you forgotten?
Yes, I think that.
So you've seen that you should be going through, okay? Angles in the same segment are equal. So that is also 35. How about this? How about the diameter? What do you remember about diameter and an angle which is subtended?
The promise.
No, the last 2 weeks, I didn't follow
Why?
the baby started the way they are.
So how are you going to follow?
I'll watch through the video.
So when there's a diameter, the angle that is in the semicircle is 90. So when there's an angle here, it is a 90-degree angle. Meaning the angle here is exactly 90 degrees. Then we also did a cyclic quadrilateral when four points of the circle are touched. When 4 points of the circle are touched, this, that, and that. When the circle is touched at 4 corners, that's a cyclic. The opposites, they add up to 180. If there's a 20 degrees here, it means the angle here will be 160. And we also said when there's an opposite, wonder why this thing is misbehaving. The network is misbehaving today. I don't know why. Keeps cutting, restarting, cutting, restarting. Who is there?
We are here.
Yes, I was saying the last rule we did yesterday was saying if you've got a cycle, and the lines touches four corners. The line touches a circle at four corners. It's hard to draw these things. And if one angle exceeds this one here, which is here, let's say 60 degrees, it is the same with the one that is outside here, 60 degrees. So today we are moving on with
You are recording, calligrapher.
yeah, I'm recording. So today we are moving on with Theorem 6. I said about 7, so 7, 8, 9. So today we want to deal with tangent. Today we want to deal with tangent, which is Theorem 7. We want to deal with tangents. Now we need to understand or know what is a tangent. So in an event, you are given a circle. An event, you are given a circle. An event, you are given a circle like this. That's a too big match. That's a too big circle. And then now you've got a line here. That's a tangent. So tangent is a line that touches one point only. A line that touches one point only. So we want to know what happens to the angles that involves tangent. We may have another one passing through like that. Maybe something like that. So we want to understand what happens when a circle has a tangent. What happens when a circle has a tangent? What happens when a circle has a tangent? Something like that. It has a line outside. So that is theorem number 7. So that is theorem 7. So it's more like we are saying rule 7. So rule 7 ikambabwa. So it is saying the angles, the tangent to a circle from an external point are equal. So let me put it in angle form. There's a circle here. Let me make it a bit small. There's a circle here, and then there's a tangent that passes through. Okay. So there's a circle here, and then now there is a line that passes through here. So if you've got such lines, which is called external tangents, out of this circle, they are equal. The angle in red, the angle in red, they are equal. This angle here and this angle here, they are equal. So if I've got 20 degrees here, this is also 20 degrees here. So that's what they are trying to tell us, that tangents to a circle from an external point are equal. So whenever you've got two tangents from the point of a circle, they are equal. Okay. Okay. So we are moving on to Theorem 8. Theorem 8 deals with the Theorem 8 states that if a chord to a circle is drawn from the point of the contact at which the tangent touches the circle, then the angle which the tangent makes the chord is equal to n in the alternate segment. So trust me, you won't understand those words. Let me put it in a drawing form so that you get it to be easier to understand. Okay. So first thing first, Theorem 8 is a last theorem. So you need to understand this theorem without difficulty, because that's the last theorem we are looking at. Theorem 8 is trying to tell you that when you have a chord, okay, so you really need to know Gabalanda chord, what is it they are trying to tell you. Okay, so where's my board? So the last theorem says. So please take note. The seventh theorem, we said it deals with a circle having two tangents. Pardon my drawing. A circle having two tangents, yes, like that. So this angle here and this angle here are equal. So two external tangents touching this circle are equal. So the angle there and the angle there are equal. If there is a 40 degrees here, even here there is also what? 40 degrees. Then don't forget rule 7. Now the last rule, which is rule 8, I will explain it in this format. There is what is called Dama chord that is under angles. So a chord is when you get a more like a non-radius line. Okay. If I get a line, I join it from any point as long as not from the center. Let's say I do this. That's a chord. So what I have, this is a minor chord, this is a major. So this is the cisegment, this thing here. So when I have a circle, and then I have something like this. Let me try to draw it in a similar manner. And then I also have draw another chord here. Okay, yes. So what I have here, these are chords. Look here. In an event, you've got something like this. This is a chord, this is a chord, this is a chord. And then you have a diameter. Remember diameter? A line that passes through the center of a circle. So here is the diameter passing through this. Okay, that's a diameter. Which now joins these other ones now. Yeah, so imagine now I have this now just extending lines, and then I have a tangent passing through. I hope you see that circle here. We're having challenges in drawing here with my cupboard. So when you have this kind of presentation here, they are saying the inner angle in red here is equal to the outer angle here. They are the same. You should always remember that. Okay. Same now, because this angle here is equal to that angle. So if I have 50 degrees here, now by 50 degrees here, that presentation should always be remembered. When you've got a tangent, you've got a diameter and this segment, you should always know that where there is a diameter, here, this diameter meeting, or if it's not a diameter, it's a radius here. This diameter and this tangent line, they make 90 degrees here in blue. Here in blue, they make 90 degrees. So meaning here I have 40 degrees here. Okay? So just like that. So if I had, so that's what the last rule says. So please, it is very straightforward. Whenever you've got a tangent, whenever you have a tangent, it passes like that. Then you have a presentation like that. You have a tangent, and on this tangent, you've got this point, you've got a diameter with, so the angle here and something like this. The angle in red here, they are equal. So this angle here and this angle here, they are equal. So please, even this angle here and the angle outer angle here, they are also equal. And this line together with this makes 90 degrees. So never forget this. Otherwise, if we have end of topic called theorem, ends like that. End of topic called theorem. Do not know if people were following or not following. So find time to do these questions, but find time to do these questions that I'm showing on the screen, and do them without having difficulties. Let me help you.
No.
So find time to do these questions. This is from 2021. Let's just wait for this artifact. They normally come on question. Yeah. So find time to do that question, copy it, and see how it's supposed to be done. Another one is just if you want to see. Let's wait for that to go away. So that's a very perfect question. Can you do? So that's all for this class. End there till we meet next time.